In many ways, the Rutherford model of the atom is the classic model of the atom, even though it's no longer considered an accurate representation. Rutherford's model shows that an atom is mostly empty space, with electrons orbiting a fixed, positively charged nucleus in set, predictable paths. This model of an atom was developed by Ernest Rutherford, a New Zealand native working at the University of Manchester in England in the early 1900s. Rutherford spent most of his academic career researching aspects of radioactivity and, in 1908, won the Nobel Prize for his discoveries related to radioactivity. It was after this that Rutherford began developing his model of the atom. The atom was first conceived of by the Greek philosopher Democritus in approximately 400 BCE. The concept was lost during the Dark Ages of Europe until 1803, when the British scientist John Dalton speculated that everything was composed of very tiny, indivisible particles called atoms. Dalton's simple model of an atom persisted until 1897, when another British physicist, J.J. Thomson, discovered that atoms contain tiny negatively charged particles called electrons. From 1897 to 1909, scientists thought that atoms were composed of electrons spread uniformly throughout a positively charged matrix. J.J. Thomson's model was known as the plum pudding model. Dalton's model of the atom depicted a tiny, solid, indivisible sphere. Thomson's plum pudding model shows electrons, the green circles, distributed in a positively charged matrix. In 1909, Rutherford conducted his famous gold foil experiment. In the experiment, Rutherford and his colleague, Hans Geiger, bombarded a piece of gold foil with positively charged alpha particles, expecting them to travel straight through the foil. Instead, many alpha particles ricocheted off of the foil, suggesting that there was something positive these particles were colliding with. They named this positive force the nucleus. The Rutherford model was created based on this new data. This diagram depicts the expected and the actual results of the gold foil experiment. The diagram on the left shows particles passing through the positively charged matrix of the plum pudding model. The diagram on the right shows particles ricocheting off of the nucleus in the center of the atom. In the years after Rutherford discovered the nucleus, chemists and particle physicists discovered that electron behavior was much more complicated than depicted in the Rutherford model. Electrons did not travel in set paths, their speeds were inconsistent, and their location around the nucleus could change based on how much energy they had. It was no longer accurate to depict electrons as traveling in straight paths. Instead, physicists began to represent them by an electron cloud that could suggest where electrons might be at any given time. The electron cloud model is the current model of the atom. Research done on electrons and the nucleus suggested that the sizes of these particles were considerably smaller than the Rutherford model showed. Thus, newer models represented the nucleus as a very tiny mass and the electrons as virtually nothing. Research also showed that the nucleus contained small positively charged particles called protons and small neutrally charged particles called neutrons. The Rutherford model shows that an atom is mostly empty space, with electrons orbiting a fixed, positively charged nucleus in set, predictable paths. Prior to Rutherford, the popular model of the atom was the plum pudding model, popularized by J.J. Thomson, in which electrons were thought to be spread uniformly throughout a positively charged matrix. Rutherford's model was created after his famous experiment where he bombarded gold foil with positively charged alpha particles. Instead of passing straight through, some of the particles ricocheted off, suggesting there was something positive these particles were colliding with. He named this positive force the nucleus. It was eventually discovered that this model does not accurately represent the behavior of electrons or the sizes of particles. The Rutherford model is one of the most popular models of the atom, even though it was only considered accurate from 1909 to 1913.